5? Starts with a C. Yeah. Common base. So what base can I make them both be? 3. Yeah. So I can make them be 3. 27 is 3 cubed to the x plus 2. 81 is 3 to the 4 to the 2x minus 1. So I'm going to get 3 to the 3x plus 6 equals 3 to the 8x minus 4. And then I get 3x plus 6 equals 8x minus 4. Shh. You have to pick an x to move to one side, so I'm going to subtract the 3x over because I'm not taking more than 3 seconds deciding which x to move. 6 equals 5x minus 4. Add 4. X, or 10 equals 5x. So x equals 2. Now you can check it algebraically. You can go 27. You can cry is what you can do. You can go 27 to the 2 plus 2 equals 81 to the 2 times 2 minus 1. So this is checking algebraically, which is 27 to the 4 equals 81 to the 3. So if I go 27 to the 4, both of them equal 531,441. So I checked it, it's good. How else can I check it? Do we remember? Calculator, y1, y2. So you could type the original into y1, this into y2, and then I look for the what? The x value of the intersection. All right. Should y1, y2, x value of the intersection. Number 2, I want you to convert from a log to exponential. The log to exponential formula is this. Y equals a to the x. And then we get x equals log base a of y. So we can use this formula. I'm going to show you how you can do it without the formula, because some people find it easier. If all you can do it is with the formula, go for it. But I told you that in order to convert, you can only have 3 pieces of information, correct? Currently we have 4. 1, 2, 3, 4. So what do I have to do with this 4? Divide it over. So now I have log base 3 of x equals 8. So we can line up the formula and do it that way. Or you can do it this way. Paying attention, every single person? What you need to realize is that the base of your log becomes the base of your exponent. If you remember that, your life will be okay. So the base of your log becomes the base of your exponent. So what is the base of my log currently?
3.
It's a 3. So I know I'm going to have 3 to the something equals something. That's how I convert, correct? So as long as you remember that the bases stay the same, and what's friends doesn't stay friends, you can convert. So the base, I have the 3 down, correct? What's currently friends in logs? The x and the 3, correct? Can it be friends over here? No. So what needs to go in this spot? There's 3, x, or 8. Those are your options. What has to go here? The 8. It's 3, x, and 8. Those are my only options. If you're saying y's or 2's or 4's or 7's.
8 by 4.
Oh. Yeah. So this would be a 2. And this would be what? What's the only other thing left? X. Oh my goodness. Okay. So whatever the base of your log is becomes the base of your exponent, and what's with it in a log cannot be with it in exponential. Okay? Let's go the other way now. The base of my exponent becomes the what? The base of my log. The base stays the base. The base doesn't change, correct? So I'm going to get log base what? 2. Then I have to have something here and something here, right? That's how logs convert. What's with the 2 currently?
X plus 1.
So what has to be now?
X plus 1.
No. What's with it doesn't stay with it. So what's with it currently? X plus 1. So what's going to be with it now?
3.
The 3. And what's it going to equal? X plus 1. So what's with it can't stay with it. So if x plus 1 is with it currently, it's not going to be with it in the log. If that doesn't work for you, use the formula. But some people, this is way easier than the formula. Okay, we're flipping to our notes. The ones that I handed out to you before were on page 6. So, they want us to solve algebraically. If you're ever given a log and you're asked to solve algebraically, if the variable's beside the log or the variable's in the base, you have to convert to exponential. So actually when you solve a log, you convert to exponential. When you solve an exponential, you convert to a log. You don't actually solve an exponential doing exponential things unless you could do common base. So I want to solve a log, and my x is locked beside the log. Do you see that? It's locked in there. The only way I can get it back out of there is to convert it to exponential. So the very first step I have to do is convert to exponential. Now remember, in order to convert to exponential, I have to have 3 parts. I have 1, which is the 6, 2, which is the x plus 3, 3, which is the 4. Do I have 3 parts? Yes, so I can convert to exponential. How do I convert to exponential? Well, the bases always remain the same. So the base of my log becomes the base of my exponent. So in order for it to be a base of an exponent, it needs to have an exponent, correct? What is the exponent on the 6?
X plus 3.
Nope. What's with it currently is x plus 3. Can it stay with it? No. So what's going to be the exponent? 4. And it's going to equal x plus 3. So what's friends in logs cannot be friends in exponential. Okay? Now this one doesn't want me just to convert. It wants me to solve. And solve means x equals number. We agree? So what do I still have to do to get x by itself? Minus the 3. So I'm going to get x equals 6 to the power 4 minus 3. Now type that into your calculator. So that's our answer. Now, we are always, doesn't matter what unit we are in, if it says solve, we are checking our answer with our calculator. We agree? Or we could plug it back into the original and see if it matches. Yes? So, I'm going to check algebraically. So I'm going to go log base 6 of 1293 plus 3 equals 4. So I'm going to get log base 6 of 1296. And I'm going to hope it equals 4. Is everyone paying attention on how the heck to type that in? Everyone's paying attention? Everyone's getting out their calculators? And we're going to do this. If you have the TI-83s, ignore me right now because this will not work for you. If you have anything higher than a TI-83, you have this beautiful log button that you should actually thank your calculator that it's great to do this. So I want to type in log base 6 of 1296 and see if I get 4, right? So I'm going to go to my calculator and I'm going to go math. And then I'm going to arrow up because it gets to the bottom faster. So I arrow up and I pick this log base button, A. So math, and I arrow up to A. You could arrow down to A, it doesn't matter, you get to A eventually. Just arrowing up gets you there faster. Hit enter, and then we're just typing in the numbers. 6 and 1296. And I get 4. So I know I'm right. So whenever you solve, you can always check algebraically if you're right. Every single time, correct? Every solving question, you should be walking away going, man, I am so brilliant, I got this right, or ugh, it's wrong, and I don't know why, so I'm going to try again. Okay? You should know if you got it right or wrong. Sam, can you not? That's that. Thanks. All right. So, if you have the TI-83, does anyone in here have the TI-83 that doesn't have the button? If not, okay. I'm going to show you. You're all going to follow along and do it this way as well, because if you don't have the log base button, you can do it this way, and it's good practice anyways. If I want to type in to my calculator log base 6 of 1296 without the log base button, I'm going to show you this. Log base 6 of 1296. And you don't have the log base button, you do it this way. You draw a line completely underneath it and split this up and put a log in front of this one. Everyone try it out. So go log, I don't care if you have log base button, you're trying this out because it's a good thing to try out. Log 1296, close the bracket, divided by log of 6. So if you have the TI-83s or the TI-84s that don't have the log base button, you have to do it this way. Still get 4, same answer, right? Doesn't matter. Same work, just a different button. Make sense? Okay. So, we're going to try this one now. Where is my variable? In the base. We see that? If the variable's in the base or the variable's beside the log, I have to convert to exponential every single time. It's the only way I can get that b out, because I need b equals something in the end, and I don't know how to solve that with a b sitting there. So what do? I convert to exponential. So the base of my log becomes the base of my exponent. So base is b, so my base of my exponent is b. In order for it to be the base of an exponent, it needs an exponent, correct? So what's the exponent that it's going to get? 2. Because what's friends in logs is not friends in exponential, right? And so it's going to equal what the friend was before. What is the friend? 144. And now I just have to solve. How do I get b squared by itself? Yeah. To square root it. When you square root, you get the plus or minus. So I'm going to get b equals plus or minus 12. The catch? The base of a log or what's beside a log can't be negative, just so you know. If you were typing into your calculator log negative base negative 12 of 144, it's going to error you. So what we write is we say b equals 12. We box that one. And we say b equals negative 12. We circle it, put a line through it, and say extraneous. Because you can't have a negative base. And you would know that if you actually did the algebra for it. So here I'm going to go and check algebraically. I'm going to check for b equals 12 first, and then I'm going to check for b equals negative 12. You always check your solutions. So I'm going to get log base 12 of 144. I put what's beside my log in brackets always, equals 2. So type log base 2 of 144 in your calculator, whichever way you have to do it. You can use the base button, or if you don't have the base button, you're going to go log 144, close your bracket, divided by log 12. Everyone is doing it. Everyone's trying to get the answer. And what do you get? 2. And the reason why you're getting 2 is your calculator is going 12 to what power is 144, which is 2. That's what your calculator. Every time you put typing a log base in, it's saying the base to what exponent gets me 144. That's what your calculator is doing every single time. So we get 2 equals 2. That one's good. Let's try the negative 12 one. Log base negative 12 of 144 equals 2. Typing it in. There should not be a phone in this room right now. It gets you non-real. Everyone should type it in so you know what it looks like when it fights you. So it's extraneous. Non-real answer means it's extraneous. It means it doesn't work. And the reason why is this number down here, this base, can't be negative. It cannot be negative. If it's negative, it doesn't happen. So this actually doesn't work. And that's why you get an extraneous. Okay, we're going to try C. The base is beside the log. Do you see it? If the base is beside the log, I have to, if the base is the variable, I have to convert to exponential. That's the only way I can solve it. So the base of my log becomes the base of my exponent. In order for it to be a base of an exponent, it needs an exponent. What's its exponent?
3 over 2.
3 over 2. And what does it equal?
123.
123. How the heck do I get rid of 3 halves as an exponent? You could 3 over 2 root it. It's really weird, but you could do it. But what you can do is you need to have an exponent of 1. We agree? So if I think about it, I think, what do I have to multiply this by in order for it to turn to a 1? So if I multiply 3 over 2 by 2 over 3, does that create 1?
Yes.
I get 6 over 6, doesn't it? So you just multiply by its reciprocal, or raise to the power, multiply the exponent by its reciprocal. And what you do to one side, you have to do to the other side. That cancels. So put b to the power of 2/3. Remember, if you have a calculator that exponent doesn't pop up, you have to put the 2/3 in brackets. If you do have the exponent popping up, you can just go 2/3. Every single person is typing it in and not on their phones. Because just because someone beside you can type it in and get the right answer doesn't mean you can. So it's 24.7. Okay guys, I have to tell you, you have to look for rounding rules on your test. If it says to the nearest hundredth and you actually find to the nearest whole number, who said 0? Because your numeric response, what's it going to do? It's just going to shoot through a machine and it's going to say yes or no to what numbers you have. That's it. There's no heart. It doesn't love you. It's a machine. Okay? You have to read rounding rules. You have to read rounding rules. You have to read rounding rules. On the next test, in the written response and the numeric, if you do not read rounding rules, I'm giving you 0s on all of them. Because I feel like you need like a little bit of shock value or something, because no one's listening to me. There are still so many people not rounding. It's not like a joke. It's not like it's like there for fun and you can ignore it. You have to read everything and highlight the rounding rules. Take a highlighter and highlight. If it says to the nearest tenth, to the nearest hundredth, you highlight that and then do that. Okay? I don't actually think it's that you can't round. I hope it's not that you can't round. I think it's that you're just not reading. Okay? Either way, if you can't round or don't read, you're just getting no marks. Right? Which sucks. So I don't want that to happen. Okay. So what did I round this to? The nearest what? Tenth. 1 decimal place is tenth. 2 decimal places, hundredth. Right? It's often, or whole number means no decimal places. We agree? All right. This one people convert. No. Why don't I have to convert this one? There's all numbers on that side. I just need to plug in my calculator, right? That's all I have to do. Please don't convert if it's equal to y. I put this one on here because so many people convert. Don't. You only convert if the variable's in the base or beside the log. If it's equal to it, you just type it in your calculator, and you'll get y equals a half. Now some people will say, how can you do that in your head? Because I know what the calculator's doing. The calculator's saying 36 to what gets me 6? What the square root of 36 gets me 6, correct? The square root is just something to the half, is it not? That's why your answer is a half. Because 36 to the half is the same as the square root of 36, which is 6. Yeah.
What is a log in mathematical terms?
A log in mathematical terms, it's just like, you'll see a graph of it. So like exponential graphs grow exponentially higher in the y's. log graphs will grow exponentially higher in the x's or grow exponentially lower in the negative x's. So a log graph actually curves like this and shoots that way long forever, or this and shoots that way long forever. It's often used in like pHs in like chemistry, because pHs are base 10.
Yeah.
That's
That
why.
doesn't have any sort of formula for it.
No, it's a log of base 10. It's a way to solve an exponential equation, right? So it's just the inverse of an exponential. All right. What do these say?
Your turn.
What do I make you do when it says your turn?
Do it.
Do it.
It's our turn.
It's your turn to step up. Okay, go. All right, so the first one we have to convert from a log to exponential because the variable's missing beside. So we do base of our log. We need an exponent to go with it, so it's going to be the 2 equals 2x minus 1. And I'm going to tell you right now, easiest one, done the worst. Almost every single person asks me how to do this one. Because you look at the 4 squared and you're trying to solve for it, and I get it. I get that it's confusing, that's why I put it first. But remember, if it's 4 squared, just write it as a 16. Show all your work. So you go 16 equals 2x minus 1. And when I had people do that, they were like, oh, never mind. Add 1, 17 equals 2x, divide by 2, x equals 8.5. Now I asked you to check algebraically, which most people did. We are now going to go behind and check graphically. So get out your calculators. You're going to y1, y2. What does my x max have to be at least? What does my x max have to be at least? 8.5, right? Type it in. Okay, unless it's numeric response. All right, so we're typing it in. Every single person is typing it in. I love that you're depending on me to type it in. However, I don't write your tests. I make the tests, but I do not write it for you. So if you call me over and you're like, where's the log base button? I'm just going to be sad. And I'm going to walk away sad. Okay? So we go math. Get to our log base button. If we don't have the log base button, no big deal. You're going to go log 2x minus 1, close the bracket, divided by log 4. It gets you the same thing. So we're going to go log base 4, 2x minus 1. If you don't have the log base button, you would put this. Log 2x minus 1 divided by log 4. So either of these are acceptable. They are the same graph. If I press graph, watch. Blue, red. They're the exact same graph. So whatever method you have, use. I would use log base if you have that one. Now, what's going on?
He dropped his calculator somehow. 6 feet.
Good. Okay. Press graph. I know that my x max needs to be at least 8.5 in order to find 8.5. Since you already have answers, you know your x needs to be at least greater than the answer, correct? So if your answer is 1024 and you max out at 10, your calculator is not finding it. Okay? So we go second, trace, 5, enter, enter, enter. Maturity sometimes, guys. I should be able to podcast this class. It's ridiculous.
Are you?
Yeah, I am. You need to make sure you're near the blinker, like the blinker's where you're trying to find. And you get 8.5. Good, done. This one, the base is missing. So if the base is missing, I have to convert. The base of my logarithm is base of my exponent. In order for it to be the base of an exponent, it needs an exponent, which is 3 equals 27. And then I need to take the cube root. Cube root doesn't get plus or minus, only squares and 4s and 6s. So even roots get plus or minuses, odds get just whatever it is, because you can take this. You can take the cube root of a negative number. The answer will just be negative. So we get m equals 3. y1, y2, we're trying it out. I know m equals 3, so I know that I need to at least have an x max of 3. If you don't move the cursor near where the cross section is, you're not finding it, just so you know. Answer is 3. Same answer. Okay, then this one. I do b to the 5 halves equals 24. How do I get rid of 5 halves? I raise to the power of 2/5. I have to raise this to the power of 2/5. So I get b equals, I type that into my main screen, 3.6 to the nearest 10, if I ask you. This one, I can't convert currently, because I have 1, 2, 3, 4 pieces of information. What am I going to have to do first?
Divided by 2.
Divide both sides by 2. And then actually remember to divide the 4 by 2, which I didn't do in the very first example. Log base 6 of x plus 1 equals 2. Then I can convert because I'm missing the variable beside the log. So if it's in the base or beside, I convert. So I get the base of my log, which is 6, needs to go to an exponent, which is 2, equals x plus 1. And then I get 36 equals x plus 1. Subtract 1, and I get 35. When I type into my y1, y2, I type the original. So I'm going to type this, and I'm going to type this. The 2 log base 6, x plus 1, and the 4. My x is 35, so is my basic window of 10 going to help? No, I need to make my x max bigger than 35. So I'm going to go y equals 2 log base 6 of x plus 1, 4, I make my x max, oh my gosh, I'm struggling, 36. So it should be happening over here, looks like it is, second trace 5, need to be closer to where it's happening. 35. Okay, then this one I have to divide the 6 over first. So I get 2 equals log base x of 3. So I get x to the 2 equals 3, and then I take the square root of that. Is it 1.7? Square root of 3? And then this one I get 3 to the 2 equals 2x plus 3. 3 to the 2 is 9. Subtract 3. 2x equals 6. Divide by 2. X equals 3. So can we check these all algebraically? Yes. Can we check them all graphically?
Yes.
Yes. Okay, what if I give you something like this? I have 2 logs. If I have 2 logs, I'm going to have to convert twice. Convert once to get rid of a log, convert twice to get rid of the next log. You work your way from outside in. So we're going to, this is what's sitting beside my log currently, right? This is what's sitting beside this log. Here's a bracket, here's a bracket. So do we have 3 pieces of information? We have a base. What's beside our log and equal to? We have 3 pieces of information. It's true. Every time you convert, you get rid of a log. Every time you convert, you get rid of a log. So the base of my outside log is 2. What is it going to be to the power of? 3. And it's going to equal log base 2 of x minus 7. It equals what's beside it. Which I can write that as 9 equals log base 2 of x minus 7. Now I need to get rid of another log. What am I going to have to do? Convert again. So however many logs you have embedded is how many times you have to convert. So now, base of my log becomes the base of my exponent. What's with it doesn't stay with it, so it's to the exponent what? 9 equals x minus 7. And then I'm going to go 2 to the 9, which is 512. Equals x minus 7, and then I add 7.
2 to the 3 is 8.
It's 8, not 9, Miss Lepp.
Oh, this is so disappointing. I've ran out of ways to fix that. Yep. What's 2 to the 8?
256.
Thank you. Oh, that's a 7, not a 1. I got a little erase happy. So it's 263. So if I go to y1, y2 this, which you can y1, y2 that. If you go to put in y1, y2, what's my x max have to be bigger than? 263, or it's not happening, right? Okay, we're done log solving. What if I ask you to solve exponential? So we've solved some exponentials already, haven't we? By common base. We did it today. We solved by common base, correct? So if you make them all be base 2, you can solve it. Base 4, base 8, base 6, whatever it may be, you can solve it. What happens if you can't actually do common base? Well, the only way you guys can be asked to do algebraically is by converting it to a log. They don't make you log base 10 both sides like in 30-1. So if I can't do common base, I have to think, okay, I'm solving by converting to a log every single time. So when it says solve and it's an exponential, I check for common base. If I can't common base, I know I have to convert every single time. Those are your 2 options. So the base of my exponent becomes what? The base of my log. Remember, base is base. It doesn't change. What's friends doesn't say friends. I need something beside this log. What do I have to have beside it? The 7. And what does it equal? What's left over? X. Type it in. Can I y1, y2 it? Can I y1, y2 to check it? Every single solve, when there's only one variable missing, you can y1, y2. Now, what if it says solve algebraically and you give me an answer by y1, y2ing it? You get a big old goose egg of 0 because you didn't do anything algebraically, actually. Okay, what's my problem here? I can't make common base, but I also can't convert currently. Yeah?
You take 4 out of both sides.
Yeah, so we'll subtract 4. So we're going to get 8x equals 36. Can I make common base? So I must what?
Log.
Log. If I can't make common base, I convert to a log. Do I have 3 pieces of information? Yep, so I can convert. So log base what?
8.
8. Because the base of my exponent becomes the base of my log. Now I need something beside it. The 36. And it equals
X.
x. The nearest tenth is 1.7. Now, is it always to the nearest tenth? I'm telling you today to do the nearest tenth. But what if I tell you to the nearest hundredth and you give me to the nearest tenth?
Wrong.
Wrong. Okay, this one. I see an exponent in the variable, and I'm like, a variable in the exponent, sorry. And I say, wait, I can't do common base. So what am I going to have to do?
Log.
Log. So log base
5.
5. What goes beside it?
30.
And it equals.
X minus 3.
And then what are we going to do? Add 3 to get it by itself. Now, do you see how the 30 is closed bracket? You have to type it in like that in your calculator too. Log base 5 of 30 plus 3 equals x. So if you're someone with that TI-83, you're going log 30 divided by log 5, hitting enter, and then adding 3. So you're doing this first, log 30 divided by log 5, hitting enter, and adding 3. And I get 5.1. Remember, you should be trying it in your calculator, because just because I can get the answer doesn't mean you can. Practice, practice, practice. D, I can't make common base. Is there anything I could do? Divide the 2, because I can't convert to a log because I currently have 4 things. I do not put these together as a 6. There are going to be people on the test who are going to do 6 every time, and I don't know how to get you to stop. You cannot make the 2 join the 3 because the 3 has a exponent. That's the reason why you can't. But you can do dividing by 2 because you were taught in grade 3 that 8 divided by 2 is 4. That's a legitimate thing you can do. So we have 3 to the x plus 3 equals 4. And then I convert to a log. Log base 3, beside, I put in brackets, a 4. And it equals x plus 3. And then what do I have to do? Take out 3. Subtract 3. And I get x equals log base 3 of 4 minus 3.
What's negative 1%?
Is it? There are 3 your turns. Keep going. Okay, so we're going to go log 6 divided by log 2. Okay, remember to do this in steps. You do this first, subtract 3, divide by 2. Now, if you're someone who wants to put this all in at once, you can, if you have the fancy calculators, and you use alpha y equals enter. If you use the fraction, remember where the fraction gets you a full numerator over a full denominator? If you type it in there, try that. Type it in there, you can put it in all at once. It will work.
What if you bracket?
That would work. So you should get negative 0.2. Okay. Quiet, please. Divide by 3. We get 3 to the 5x plus 1 equals 21. So we get log base 3 of 21 equals 5x plus 1. I'm telling you, people will be able to do the math right, and then they can't put in their calculators because they never touch their calculator and bank on my answers. And that's scary for me. So everyone should be using their calculators to make sure they get the right answer. If you use alpha y equals enter, if you use the fancy calculators, you can type it in all at once. Numerator and numerator, denominator and denominator, right? You can. You just have to use that button. If not, you have to do it in steps. Do the log first. Get your answer. Subtract 1. Get your answer. Divide by 5. Get your answer. And x equals 0.4. Centimeters 10th. And this one I get log base 2 of 3 equals 3x plus 2. Subtract 2. Tomorrow we're going to do log, and you're going to go home with a 10-question assignment that's due on Monday on logs and exponentials.